Hi everyone and welcome back. In today's lesson we are going to have a look at a combination of identities and reduction formula. Now let's jump straight into an example. Now we are asked to prove the following identity. So we want to show that this left side is equal to 3 sine squared x. So we're going to simplify this left side as far as possible and hopefully we will end up with an answer of 3 sine squared x. So here we go. So here we can see that this is a reduction formula because this is 90 degrees and we can rewrite it in terms of its acute angle. So we go to 0 degrees and we go 90 anti-clockwise and then we go minus 2x, which is clockwise, and we end up in the first quadrant. Now we are given a cosine function and in the first quadrant it is positive, so we write the plus. And then we change the cosine to a sine function because there's a 90 and we write the acute angle next to it. There we go. Then we put it in brackets because remember this is a cosine function times a tangent function. And now we do the same with this tangent function. So we go 360 degrees, start at 0, that is again anti-clockwise, plus x, which is anti-clockwise again, and we end up in the first quadrant. Now we are given a tangent function. In the first quadrant it is positive, so we write the positive sign, we write the tangent, and then we write the acute angle. It goes in brackets because again they are being multiplied. And I don't have to write these pluses, but I show you what to do in case they were negative anyway. Okay, then we write the plus and we focus our attention on the second term. Now there's two things I want to do here. I don't want such a large angle. We always want 360 or less. And I don't want the square here because I'm going to do reduction formula. So I'm going to write it in a way so that it's in a different place. So I'm going to open up a bracket. I'm going to write the sine function. Then 540 minus 360 is 180 plus x. And then I close the bracket off. And I write the square on the outside. Okay, wonderful. So this means exactly the same as this. Now that we are done, we can simply multiply these two and get rid of these brackets. And we end up with the sine 2x and the tangent x. And here we can do reduction formula. So we write the plus and we leave the bracket. And then we go to 0 degrees, 180 anti-clockwise, plus x also anti-clockwise. And we end up in the third quadrant. Now we're given a sine function. In the third quadrant it is negative. So we write the minus, we write the sine function, we write the acute angle, we close the brackets off and we write the square on the outside. And there we go. So what we can do next is we can simply try and solve this by trying to simplify. Well, I take this term plus this term, I cannot. And then we go to the second step, which is factorization. I cannot factorize these two because that's totally a different angle from x, even if I do the square. So I cannot factorize. And therefore it leaves us only with identities. So a sine double angle becomes a sine double angle, which gives us 2 sine x cosine x. So I'm going to take this and I'm going to put it in the place of the sine double angle. So here we go. And I'm going to take it and I write it in brackets because I'm still multiplying it with the tangent. So then I take this tangent x and I change this with the quotient identity. So I take it and I substitute it into the place of the tangent x. And now lastly, I can just simply do the square, and a minus squared gives us a plus, and sine x squared is sine squared x. Okay, wonderful. We keep simplifying now again. So this cosine x and cosine x cancels out, and 2 sine x times sine x gives us 2 sine squared x. And then we still have the plus sine squared x. Now here we have 2 sine squared x plus sine squared x. They are exactly the same 2 sine squared x's because they've got the same angle. So they're actually in the same triangle. So we've got 2 of these ratios plus 1 of these ratios, which gives us 3 sine squared x. And that is equal to our right side. And we are done. See you again next time. Bye.